Next session in our syllabus is counters, definition, modulus concept, timing diagram, types and applications. Okay, so we are studying what are counters, what is modulus of a counter, what is its timing diagram, and types and applications. Okay, first let us see what is a counter. So counter, definitely it is a register. Okay, counter is nothing but a register which is used to count the clock pulses. Used to count the clock pulses given to the input of the counter. Okay, when the clock pulses are inputted to it, how many clock pulses are given as the input, that will be counted. So the definition for counter, it is a sequential logic circuit and it is a register used to count the clock pulses. See, if we have a 4-bit counter, 4-bit counter, then we can count starting from 0000 to 1111. Okay, so up to 2 to the power 4, which is equal to 16. This many counts we can count. So including 0, it is counting 0 to 15. So we can count totally 16 combinations and the numbers are 0 to 15 using a 4-bit counter. Similarly, using a 3-bit counter, we can count up to 7. We can count from 0 to 7. That means total 8 counts we can do, we can perform. Okay. And the basic units of counters, as we have seen for the registers, shift registers, the basic units are nothing but the flip-flops again. Okay. Different types of flip-flops may be incorporated to build a counter. So if it is a 3-bit counter, then we need 3 flip-flops like this, 1, 2, 3. If it is a 4-bit counter, then we need 4 flip-flops. So now modulus. What is a modulus? Concept of modulus, right? So modulus is nothing but the maximum number of counts, the maximum number of counts which are obtained from that counter. Okay, if it counts up to 0 to 7, then it is a 7 mod 7 counter. We call it as mod. Okay, mod 7 counter, mod 8 counter. Okay, mod 8 counter. It counts from 0 to 7. So total number of counts are nothing but the modulus of that counter. If it is a mod 6 counter, then it can count from 0 to 5. If it is a mod 10 counter, then it counts from 0 to 9. That's it. Okay. Binary numbers 0 to 9 can be counted, or the total number of pulses counted using mod 10 are 0 to 9. It can count from 00002, or the output of the counter will be 0002 1001. Okay. So when the next count comes 1010, that is nothing but 10 comes, it is to be reset again to 0. Okay. This is the concept of modulus. Modulus is nothing but the total number of counts. Okay, total number of counts which are done using that counter. Mod 6 counter counts totally 6 numbers or 6 pulses. So mod 6 can count from 0 to 5, including 0, it is 6. Next, what is the timing diagram? Timing diagram. So timing diagram is nothing but the number of clock pulses along with the inputs. Okay. So if we write the clock pulses like this, it is nothing but a square pulse. We know this. And if we, along with this, if we write the outputs for the respective output of the respective flip-flops with respect to the clock pulse. If it triggers at the positive edge triggering, then the output may change in the in that edge, okay, in that time interval. If it is a negative edge triggered clock pulse, then the output may change at the negative when the negative edge arrives. Okay. See, if it is a toggle flip-flop, for each of the negative edge triggering, or for each of the negative edge, the output will change like this. Sorry. The output must change here. So the output changes whenever the negative edge comes. If it is a negative edge triggered flip-flop, then for each and every negative edges which are shown here for the clock pulse, this is the clock pulse, and if this is the output Q, then for each and every negative edge, the output must change like this. Okay, it has to toggle. If this is the next pulse, the output will change somewhere here. So timing diagram is nothing but representing the output with respect to the clock pulse. So depending upon what type of flip-flop we are using, if it is positive edge triggered or negative edge triggered, depending upon that, so the output is represented at that time interval of at that time interval. So this is timing diagram. What are the different types of counters? The different types of counters. There are several types of counters. Okay. So the first main classifications are whether it is asynchronous or synchronous. So this depends upon how we give the clock pulse to the counter, whether it is synchronous or asynchronous. Asynchronous means the clock pulse is given to the first flip-flop, and for the rest of the flip-flops, the clock pulse will be from the output of the previous flip-flops. Okay. For the rest of the flip-flops, output of previous flip-flop will be the clock pulse. So see, if we have three flip-flops like this, for the first flip-flop, the clock pulse is given directly. This is the clock pulse. For the next flip-flop, the clock pulse is from the output like this. Okay. So this is called as asynchronous. That means at a time we are not giving the clock pulse as we have done in the shift registers. Okay. So in asynchronous type, the clock pulse is given only to the first flip-flop. The rest of the flip-flops are getting the clock pulse from the previous flip-flop output. Synchronous in the sense clock pulse is given at a time to all the flip-flops. This is done in the shift registers, right? So if we have the flip-flops like this, to all the flip-flops, the clock pulse is given at a time like this. Okay. So all the flip-flops, they get the clock pulse together. So that is called as synchronous. They are all in synchronism. Synchronism is nothing but at a time they are receiving the signal. Okay, the clock signal is given together to all the flip-flops. So depending upon whether it is asynchronous or synchronous, there are few more types of counters. So this asynchronous is also called as ripple counter. Okay, asynchronous counter is also called as ripple counter. So here we are going to study what is a 4-bit ripple counter. And also we are studying what is a mod 10 counter, and this mod 10 is also called as decade counter. So these are the different types of asynchronous counters. So 4-bit counter which counts from 0 to 15. Okay. Mod 10 counter, it counts from 0 to 9. So we can design any modulus counters. They're all asynchronous counters. Okay. We can design from mod 3, mod 4, mod 5, or any number of counters we can design depending upon our requirement. So synchronous is nothing but the counter which has the clock pulse together. There are other types, like we can have the counting in which direction we need the counting, whether it is in the ascending order or it is in the descending order. We have two more types, that is the up counter and the down counter. Okay. The counter may count in the ascending order, then it is called as up counter. If it counts in the descending order, then it is called as the down counter. Also, we have some other types like ring counter, Johnson counter, Johnsson. Okay, these are the other two types of counters. Few counters may be used as universal counters, which does the operation both in the ascending order as well as descending order. It can count even in the up direction, or it may behave like the down direction also. Down counting is also possible using that counter. That type of counters are called as up down counters. So some of the types, to revise, asynchronous and synchronous is the main classification of counters. Under asynchronous counter, we have several uh, bits of counters like 2-bit counter, 3-bit counter, or 4-bit counter. It may be up counter or down counter. Again, we have modulus counters. So synchronous counters, again, we may have 3-bit or 4-bit or any number of counting. Also, we may have up and down counting. And depending upon our requirement, we may design counter like ring counter or Johnson counter. These are some of the types of counters. Okay. So next we have the applications of counters. So the main applications of counters are in counting the pulses. The main application is counting the pulses. Just to count the pulses, mainly these counters are used. Counters are also used in counting the speed. Okay, counting the speed. They are also used to measure the distance, or measure the speed, measure the distance. They are used as the frequency generators. Okay, frequency generation is the other application of counter. They are also used in frequency generation, or waveform generation also is one of the application. Okay, frequency generation or waveform generation. They are used as the frequency counter also. Along with the generation, they are used as the frequency counters. They are used as for the multiplexing purpose, parallel to serial data conversion. See, in auto parking control also, if to count the number of parked vehicles, whether the place is available to park or not. So by counting the number of vehicles, while counting the number of vehicles, counters can be incorporated. And by seeing the number, we can say whether the parking place is available or not. So that can be displayed. So in many of the fields, these counters are used. The applications are very wide. So in many of the digital applications, these counters are used. These are the few of the applications of counters. So in this session, we have studied what is a counter, what is modulus, what is timing diagram, and also different types of counters. Along with that, the applications of counters we have seen.